Page 3, number 11. Remember to read it first and then come back. This is a calculator question. A school janitor uses a cylinder trash can to collect garbage from classrooms. Okay, the only part there that's important is the fact they tell you it's a cylinder. The rest of it you can just ignore. The janitor makes an average of 5 trips to empty out his cylindrical trash can into the main dumpster behind the school. So 5 trips is how many he makes to empty out one trash can. The janitor wants to be more efficient and only go to the dumpster once at the end of his shift. So he doesn't want to go 5 times. He doesn't want to do 5 trips. He only wants to do 1 trip. To accomplish this, he will have to get a larger trash can. How much should his new trash can hold in cubic inches? So your goal is to figure out how much the new trash can hold in cubic inches. There's a couple of really important things that happen here in the ask. First thing that you should note is that it gives you clues as to what to solve for. It's telling you hold. When you're talking about how much something can hold or fit into something, you're talking about volume. So you have to recognize that this is going to be a volume question. If that didn't tip you off, they're asking for your final answer in cubic inches. In other words, inches to the 3rd power. That is only for volume. Thinks the 3rd power is for volume. So those 2 things should clue you into the fact that you're looking for volume. Not just volume of this one trash can. He wants to have a larger trash can that can hold 5 times the amount that this one holds, so that he only has to make 1 trip to the dumpster. So imagine this is your trash can for 1. Then you are going to have 5 of them. So multiply what this can hold by 5 in order to figure out how much the new trash can should hold. So let's think about what we need to do. We need to get volume, then we need to get that volume, and we need to multiply it by 5 to get the new volume of your trash can. Okay, so let's think about the volume formula. Now, on your reference sheet, you only get a couple of volume formulas, and they're very generic, and they don't tell you what they're for. If something does not have a point, an apex, a big point at the top, like a pyramid or a cone, your generic volume formula is going to be V equals big B H. Big B is not a number. Big B is hiding a formula behind it. It's hiding the formula for area of your base. Now, if we have a cylinder, our base is in the shape of a circle. So the base of any cylinder is a circle. So our formula for any cylinder is going to have big B replaced with the area formula for a circle. So if you want to memorize that for a cylinder, you don't really have to do big BH. You need to memorize that you're going to have to do pi r squared times h. Always, always, always if it's volume of a cylinder. But if it's not a cylinder, don't replace big B with pi r squared. All right, let's take a look at our information. Remember that we want to get inches cubed. They show us a height of 26 inches. And they give us this width for the trash can, which really is your diameter, but they give it to us as 1 foot. You cannot have feet in your equation. They want inches cubed as your final answer, so you have to convert. In 1 foot, you have 12 inches. So instead of writing 1 foot, I'm going to replace this with 12 inches. Now, I need the radius and I need the height. I know the height is 26, but my radius is not 12. My radius is from one end of the circle to the middle of the circle. So it's half of your diameter. So we're not going to use 12. We're going to divide 12 by 2. And now we're going to get 6 inches as your radius. So let's plug all of this into our equation. V equals pi, the radius is 6, squared, times your height of 26. All of this is in inches. Now we're going to multiply across, but we're not going to multiply the pi in just yet. So let's go to our calculator, start with the 6 squared. 6 squared is 36 times the height of 26. And you get 936 times pi. So I'm going to go back to my work here, and I'm going to put that it's 936 pi inches cubed. But don't let yourself think that it's 936 as the volume. It's 936 times pi, which is 3.14 yada, yada, yada. You are no longer going to use 3.14 in this class and on this EOC. You're going to be exact, and you're going to use the pi button in the calculator. So I'm going to go back to my calculator. I'm going to click times multiplying 936 by pi. Pi is right here for me, and on your calculator, make sure you locate it before you start your test so that you know where all of the buttons are. Times pi. Now it pops up that pi is this long, long infinite decimal. So it's much more than just 3.14. So it's telling you, are you okay with using this decimal? And you say yes by clicking equals. So it's about 2,940 cubic inches once you've multiplied pi in, not 936. So it's approximately 2,940. Let's go out a couple of decimal places here. Let's say 5307, and then we'll keep it there. Out 4 decimal places. Now that's for one can. That's for the one can that he has currently. He wants a larger can. He doesn't want to have to go to the dumpster 5 times. So it should hold enough, or it should hold as much volume as 5 trash cans would hold. So we're going to take this volume and we're going to multiply it by 5, times it by 5, because that's how much the new trash can should hold. So go back to your calculator, click times 5 equals. That's how much the new trash can should hold. It's 5 times the volume of the old trash can. That's our final answer. Let's round it to, what does it say to round to? It says round to the nearest whole number. Okay, whole number means you're not going to put a decimal. So the 2 is either going to round up to 3 or it's going to stay at 2. Looking next door, the 10th place, the 6, says the 2 should round up. So our final answer that you're going to put right here is going to be 14,703 inches cubed. That's how much the new dumpster should hold. You should be putting this formula, volume equals pi r squared h, on your reference sheet. I would recommend even putting a little visual to show that it's for a cylinder. Let's move on. Question number 12. Again, read it and come back. Again, this is a calculator question, so let's go through. The tennis balls are packed tightly and are flush with the edges of a newly designed tennis ball container. The new rectangular label will wrap around the container and cover 56% of the lateral area. Okay, so we're talking about a label, a rectangular label. It's going to wrap around the container and cover 56% of the lateral area. The lateral area is the curved portion of a cylinder. So you don't include the circle at the top and the circle at the bottom, which are your bases. Question is, how many square inches will this label take up to the nearest tenth? So we're looking for how many square inches. Inches squared is an area concept, but they've already told you it's lateral area, so you know it's area. Now the question is, well, what's the lateral area formula for a cylinder, which is what this container is? It's a cylinder. Now, if you've memorized your surface area formulas, which you don't get on the EOC, and you need to make sure you memorize, look like this. Surface area for a cylinder is the formula 2 pi RH plus 2 pi r squared. Now, the beginning of this formula is the lateral area. It's the curve. 2 pi r squared represents the area of 2 circles, the top and the bottom circles. That's for all of the surfaces. That's the surface area. But they're just talking about the lateral area, because when we put a wrapper around a cylinder, it's going to go just on that curved part. So let's take a look at just the lateral area formula. We have lateral area equals 2 pi r h. Now, I want to think about my full lateral area, but I want to keep in mind that at the end, our new label doesn't go around the entire curve. It only takes up 56% of that lateral area. Because when you think about it, well, a wrapper probably is going to look something like this. Take up about 56%. It's not going to go all the way top to bottom. So it makes sense that we don't want the total lateral area for this new label. But before we do the 56%, we need to focus in on, well, what is the total lateral area? And then we'll deal with the 56%. Okay, let me erase this. Now we need 2 things. We need the radius and we need the height. In our visual, all they gave us was this 2.7 inches, which is your diameter. So in order to figure out the radius for the container, we're going to have to divide 2.7 by 2. So go to your calculator. 2.7 divided by 2 is 1.35. So 1.35 inches. That's our radius. So we got that. The other thing that we need is the height. Now, this is where you have to think back to what they said in the beginning of the question. They said that the tennis balls are packed tightly and are flush with the edges of this container. Meaning from the top to the bottom, all 3 of these tennis balls are touching. Now, they gave us a 2.7 inch diameter, which when they drew it horizontally. However, you have to remember that your diameter for these balls, which are spheres, will also work vertically. So 2.7 is also going to be kind of like the height of the tennis ball, but really it's just the diameter. Then another 2.7, and then another 2.7. So in total, we have 3 tennis balls with a quote-unquote height of 2.7, which gives us the entire height of the container. Go to your calculator, do 2.7 times 3, and we get 8.1. So the height of our container is 8.1 inches. Now, let's plug all of this in and let's figure out our lateral area for the container. So lateral area equals 2 pi, radius of 1.35 times 8.1. Multiply all that together. I'll keep pi for last, so I'm not going to multiply the pi in. So in my calculator, I'm going to do 2 times 1.35 times 8.1 equals. So 21.87 is my 3 numbers multiplied together, but don't forget the pi. 21.87 pi. Now, this is my exact value for the lateral area. Let's go ahead and multiply the pi in and see how much it is approximately, because we won't be able to write out the whole thing. So back to the calculator, multiply in pi. So 68.7, yada, yada, yada. Okay. Lateral area is approximately 68.706. Let's go out one more decimal, 6 inches squared. Square inches. Okay, that's the total lateral area. I only want 56%. So the way that you're going to do 56% of the lateral area is you're going to multiply. You can't have 56% in your calculator. You have to write it down as a decimal. So the way that you turn a percentage into a decimal is you take where the decimal currently is, which is right here, and you move it to the left twice. 1, 2. So it's going to be 0.2 0.56, which is 56% as a decimal, of the lateral area. Of means multiply. So multiply it by the total lateral area, which we got here, still in your calculator, 68.7066. Now, since I've left it in my calculator, I haven't really had to round yet. I rounded when I wrote it down, but not in my calculator. So now I'm going to multiply what's in there times 0.56 to get 56% of that. Equals. Now 38.47, so on and so forth. Let's see how they want me to round. They say to the nearest tenth. Okay, so to the nearest tenth, that's where the 4 is. Now look next door, it's a 7. That 7 says round up. So 38.5 square inches is going to be your total area. Let's go ahead and write that down. 38.5 inches squared. Okay, and now we're done. Let's move on to number 13. Number 13, using the same can of tennis balls in the previous question, find, and then it has 3 things that it wants us to find, but it says keep it exact. Now, when they say that, that means either keep it as an improper fraction, keep it as a square root, or in this case, it's going to be keep it in terms of pi, meaning don't multiply the pi in. So you're going to keep the pi. Now, we're going to use the same visual from before, so we need to put in some of the information that we figured out last time. So we know that this is a radius. We're going to put our radius equals 1.35 inches. We're also going to put down that this height is 8.1 inches. And now we're set up to do the question. Okay, part A. The total volume of the can is. All right, so we're asked to find the total volume of the entire can. Well, we've done cylinders before, so let's write down our volume formula for a cylinder. Volume equals big BH, but let's go ahead and replace big B with the area of a circle. So pi r squared h. Let's plug in our radius and our height. The radius is 1.35 squared, and your height is 8.1. Go to our calculator. Remember, don't multiply in pi. It says keep it exact. So our final answer should say pi and then inches cubed. So in the calculator, I'm going to do 1.35 squared times 8.1 equals. Okay? So volume equals 14.76225 pi. And that's in inches cubed. Okay, so into my question, I'm going to put 14. Let me zoom in for me. So 14.76225 pi inches cubed, because it's volume. Okay, next question. Find the volume of the empty space inside of the can. The empty space. Okay, let's look at our visual. Empty space. Well, I have the total volume of the can, and if I find the volume of each of the tennis balls and I subtract, I'll be able to figure out the volume of this little piece, and this little piece, and this little piece, and this little piece, and whatever part is not taken up by those tennis balls. So I need to remove the tennis ball's volume from the total volume of the can to see what is left for just air, for empty space. Okay, so that's our game plan. Let me write it down. I'm going to find volume of the can, which I've already done, so that's good. I'm going to subtract the volume of the 3 balls. Okay. Now, volume of the can, let me go ahead and plug that in. That's 14 point, zoom in a little bit. 14.76225 pi. And you're going to see that it's really helpful that we did not multiply that pi in. Now we have 3 tennis balls. To find the volume of all 3, which are identical, I'm going to do 3, and in parentheses, I'm going to put the volume for 1 tennis ball. Now I need to figure out the volume for 1 tennis ball. A tennis ball is a sphere, right? It's a sphere. So that means I need to write the formula down for a sphere. They do give you that on the EOC. They don't tell you that it's a sphere, but they do give you the formula. The formula is 4/3 pi r cubed. No height, nothing, because a sphere doesn't have a height. Okay, the diameter acts as the height, the width, the everything. So this is what we need to do. Now the radius of each of the tennis balls, since it's flush from edge to edge, is going to be the same as the radius of the can. So we already have it. It's 1.35. Let's go back to our work. Let's go ahead and plug in. So I'm going to do minus 3 parentheses 4/3 pi, my radius of 1.35 cubed, close parentheses. Now, for those of you that are algebra whizzes, you'll notice that 4/3 times 3 is going to have these 3's cancel. Because if you're multiplying by 3 and then dividing by 3, it's like you didn't do anything at all. So let me start with the 1.35 to the 3rd power. Go to my calculator. I'm going to do 1.35 to the 3rd power. For most of you, it's right above the 1 button, but you have to activate it. So you have to click second and then 1, and it's going to activate x to the 3rd power. For me, I have a different type of calculator, so I have to click second as well, but then I see the x to the 3rd pop up on the top left. So 1.35 cubed is 2.460375. I need to multiply that by 4. Okay, don't forget about the 4. So times 4 equals 9.8415 pi. So let me go ahead and write that down. Minus 9.8415 pi. This is the 3 tennis balls. Okay, that's the volume of the 3 balls. All right, so let me go ahead and bring down the volume of the can so I could subtract the 3 tennis balls and get the empty space. So 14.76225 pi minus that 9.8415. Go to the calculator. 14.76225 minus 9.8415 equals 4.92075 pi. Remember, just now all I was doing was I was subtracting the coefficients to pi. But pi is still along for the ride. So let me go ahead and write that down. So the empty space is 4.92075 pi inches cubed of empty space. And go on up and put that into my answer. So now I have 4.92075 pi inches cubed of empty space after I remove the 3 tennis balls volume. Last question here. What is the exact percentage of the can that the tennis balls occupy? All right, exact percentage. Now let's talk about how do you find percents. I'm going to give myself a little bit of room to write. Okay, so to find a percent, what you're going to do is you're going to do the part that they're asking about over the whole. So in this case, they're asking what part is taken up by the tennis balls. Well, the amount of space taken up by the tennis balls, we just figured it out in the last question. It was 9.8415 pi cubic inches. That's the part that's taken up by the tennis balls. So I'm going to have that as my numerator. So this piece here is 9.8415 pi. And again, you're going to be happy you kept it in terms of pi. Now the whole thing, well, the tennis balls are inside of the can, and they want to know what percentage of the can is taken up by those tennis balls. So I'm going to put the volume of the can as my denominator, which we got as our first piece. So let's go ahead and write that down as our denominator. 76225 pi. Okay, so now we just need to divide. Remember that these pi's will cancel out, so you don't even have to multiply in the pi's. Just work with the two numbers, the two coefficients to the pi's. Go to your calculator. 9.8415 divided by 14.76225 equals. All right, so it's this long repeating decimal, 0.6666666 repeating. That 7 is when your calculator is rounding it, but really it's 6 repeating all the way to infinity. So I'm going to put down that this is equal to 0.66666, so on and so forth. And they told me to stay exact, so let's talk about that. Right now it's a decimal, it's not a percentage. So I need to convert this to a percent by moving it to the right twice or multiplying it by 100 in your calculator. So if I do times 100, that's the same thing as moving the decimal to the right twice. It's 66.6 repeating. So now we have as a percent 66.6 repeating, that's the repeating symbol, percent. You can keep it like this, but on the EOC, they may not let you type in a 0.6 repeating. And you want to be exact. So you need to know that 0.6 repeating is the fraction 2 over 3. So we're going to put in, it's 66 and 2/3%. That's exact. All right, let's go to the top, put our answer in, and we'll be done. 66.6 repeating percent, or 66 and 2/3%. That one took a lot of work, so hopefully you copied all this down on a separate sheet of paper or gave yourself a lot of room if you're a really small writer. Let's move on. Number 14, no calculator needed. Find the radius and center of a circle with the equation x squared plus y squared plus 4x minus 8y equals 16. Okay, so they're asking you to find the radius and the center coordinates for a circle. Now, a circle always has x's and y's in the equation. A circle equation in standard format looks like this. X minus h squared plus y minus k squared equals your r squared. That's standard format. That's clearly not what this is in, but that's standard format. When it's in this format, your center is really easy to solve for. Your center is basically the opposite sign of h and k. So whatever you see in there, if it's positive or negative, take the opposite sign. So your center is the coordinate h comma k. Your radius is r. But r squared is always what you see on the right side of the equal sign. So there's a step-by-step process on how to convert this, which does not look like our standard circle format, into standard circle format. It's called completing the square. And I know that's weird. It's a circle. Why is it called completing the square? But it's called completing the square. So if you want to look up more information on this after we go through a couple of problems, feel free to Google completing the square. Okay, let's get started. Now, I'm going to zoom in because I'm going to focus just on this equation right here. Okay, the first step in converting something that looks like this, that has x is being squared and y is being squared, into standard circle format, is to group things appropriately. You want to make sure that your whole number, and there's only one whole number that's all by itself in this equation, you want to make sure it's on the right-hand side, which it is, and that's exactly what you want. All the rest of the stuff, things with x squared, y squared, a regular x, a regular y, you want those to all be on the same side of the equal sign. Now we're going to group them, meaning we're going to put the x's and the x squareds together and the y squareds and the y's together. So I'm going to rewrite the equation to look like this. X squared plus 4x, and then I'm going to put the y squareds. I don't like the way that turned out. There we go. Minus 8y equals 16. Okay, your end goal is to have your equation in standard format. So something that looks like this. Now to get there, you want to throw in an x and throw in a y where they belong. And now you're going to focus on the x's and the y's separately. So let's start by focusing in on the 4x. What you're going to do always is you're going to divide the coefficient to x by 2. So divide the 4 by 2. You get 2. Take that and throw that into the first parentheses. It's a positive 2. Now, that same number that you just threw into the parentheses, you're going to bring it to the right-hand side where the 16 is, and you're going to square it. So that 2, I want you to square it. Which you get is 4, positive. You're going to end up adding this to the 16. So right now you have 16 and you have 4. They're going to get added together. That's just with the x's. Let's move on to the y's. So with the y's, take the negative 8y. You're going to divide by 2, always, and you get negative 4. Take that negative 4, throw it into the parentheses, minus 4. Now that same negative 4, I want you to bring it to the other side of the equal sign, and I want you to square it, just like we did before. Negative 4 squared is 16. You're always going to get a positive number coming out of a square. So it's 16. You're going to add this to the other two numbers that we had circled before. So now, almost done. 16, 4, and 16 are going to get all added together. And you're going to get 36. Now, this is in proper standard form for a circle. And the question is, find the radius and find the center. Well, that's pretty easy now that it's in this form. So I'm just going to give myself a little bit more room. Now, your center, like I mentioned before, is always the opposite sign of what's currently in the parentheses. So instead of a positive 2, our center is at negative 2 for the x value. And then instead of a negative 4, flip the sign. It's going to be a positive 4. That's where the center of the circle is located. For your radius, you're going to take whatever number is here on the right-hand side and you're going to square root it. So square root of 36, which equals exactly 6. So imagine what the circle is going to look like. I mean, as far as the question is concerned, we're done. The center is at negative 2, 4. The radius is 6. We're done. But I want you to think about what this circle looks like. Okay? So if I kind of visualize this, I'm going to create our x and y axis. I'm going to put the center of the circle at negative 2, 4, which is maybe around here. And then it has a radius of 6, which means it goes 6 in all directions. 6 to the right, so I can put a point there. Let me actually change this. So I'll do a dotted line. So if I go like 6 to the right, maybe my next point is here. If I go 6 up, if I go 6 to the left, 6 down, okay? That's my radius of 6 on all sides. And I would connect that with a nice smooth curve. So this is what my circle would look like if it was on a graph. Okay, let's move on to the next question. Remember, your answers are right here for the center and for the radius. 15. Describe the graph of the equation x squared plus y squared plus 6x plus 10y minus 2 equals 0. Now notice there's x squareds and y squareds in the same equation. That's a circle. It's always going to be a circle if you have an x squared and a y squared there. Well, as far as this class is concerned. Now let's take a look at our choices. They're telling us about a radius and a center. Okay, so they're asking us basically, well, figure out your radius and your center. Figure out what they are, where they are. So let's go ahead and do that. This is not a proper and standard form of a circle equation. So just like the last question, we want to put this into standard form. If you remember what the first step is, it's to rewrite this so that we have the whole number by itself on the other side, and then so we can regroup and have the x's together and the y's together. So we can't just throw the -2 to the other side. We have to use our algebra. So what we're going to have to do first is we're going to have to add 2 to both sides so that we get the -2 to the other side using proper algebra rules. Now, let's rewrite what we get. So we're going to have x squared, and I'm going to bring the 6x to stand next to it, plus y squared, and I'm going to bring the 10y to stand next to it, equals the +2. Now, your goal is to put this in standard format. So our goal is going to be to have something that looks like this. Your x is in the first bubble, your y is in the second bubble. Okay, let's start. Starting with the 6. Divided by 2. Always divide by 2. 6 divided by 2 is 3. Throw that into the first bubble. +3. Take that 3. You're going to add it to the right-hand side after you square it. So do 3 squared and you get 9. So right now you're adding 2 and 9 together. We still have the y's. So now the y's, you have a +10 divided by 2, you get 5. Throw that into the bubble. And then add the 5 squared to the right-hand side. 5 squared is 25. So now you're adding 2, 9, and 25. When you add all of those together, you're going to get 36. So 36 is what we have on the right-hand side. And now let's decide on our center and on our radius. So our center is the opposite sign of 3 and 5. So it's -3, -5. And our radius is always whatever's on the right-hand side here, square rooted. So square root of 36 is equal to 6. Okay, so our radius is 6, and our center is at -3, -5. Let's take a look at our choices. Okay. Radius is 6, that's here and here. Okay, so it's not choice B, it's not choice C. Now let's compare the centers. Our centers are at -3, -5. It's the opposite sign of what's in the parentheses. That's right here. So our answer choice is choice D. Let's move on. 16. What is the diameter of a circle with that big ol' equation? Okay, so we know it's a circle equation. That's great. They're asking you to find the diameter. That's your ask. What is the diameter? Now, Our circle equation never uses the diameter. It always uses the radius. In fact, most of the formulas that we learn in this class don't use diameter. They use radius. But we know that to get the diameter, we can take the radius and multiply by 2, because the diameter is 2 times the length of the radius. Let's take a look at our equation. Well, it is not in standard form again, so that requires us to do all those steps that we did before to get to standard form. Now, step 1, make sure you get rid of that negative 12 from being on the same side as all of our other x's and y's. So we're going to add 12 to both sides. And then we're going to rewrite, grouping together the x's and the y's. So when I rewrite this, now I have x squared plus 2x plus y squared plus 12y equals positive 12. Now, create my bubbles. That's what my final answer should look like. Now let's get started. Throw in an x, throw in a y. I'm going to grab the positive 2x. I'm going to grab the coefficient, divide by 2. 2 divided by 2 is 1. Throw that into the first bubble, plus 1. Then take that, plus 1, square it, and add it to the right. 1 squared is still 1. So now we're adding a 1 to the right-hand side. 12 and 1 will end up being added together. Let's go on to the y's. So we're going to grab the coefficient to the regular y value, that plus 12. We're going to divide it by 2. 12 divided by 2 is 6. Throw that into the bubble. Positive 6. So no negatives here so far. And now we're going to add the 6 squared to the right-hand side. 6 squared is 36. Now, 36 plus 1 plus 12 is going to give you 49. So on the right-hand side of this equation, we have 49. So for our center, which they're not asking you for, but it's good to review, our center is at negative 1, you take the opposite sign, and negative 6. Our radius is always whatever's on the right-hand side square rooted. So square root of 49, it's a nice whole number, it's a 7. It's okay if it wasn't a whole number, that would be okay, but it turns out that in each of our problems, it was a whole number. Now, if you think you're done, you're not. They didn't ask you for the center and the radius. They asked you for the diameter. And a good thing is that we put this note in to remind us, don't just get the radius, multiply it by 2. So this is your radius, multiply 7 times 2. And your diameter is going to be 14 units. So just as a quick visual, what you had is you had a circle that had a radius of 7, but they wanted the diameter. So you had to get the whole thing. And these two pieces are equal. They're both 7. So your whole diameter is 14. 14 units. And that completes page 3.